All right, 16.1 properties of logarithms. So, definition property, here we have it at the top. We have a product property, which is basically saying if you have two things that are being multiplied, it's like taking the log base b of m plus log base b of n. These are much like our exponent rules. So when you're multiplying, you add. When you're dividing, we actually can subtract them. When we're raising it to a power, this one's different. Does mean multiply, but the power gets to come to the front. It's one of the advantages of using log and using log to solve equations, which we will get to in this module, is we can get rid of an exponent or a variable out of the exponent by pulling it to the front, and we do that by taking the log of both sides. And then we have the rule of change the base. So these kind of follow along the exponent rules, a little bit different, a little bit the same. We're going to practice using some and being able to rewrite as a single logarithm. So make sure you have all these rules written down. We've got 3 examples, but we're going to spend a couple of days on it in class. So here, we're going to use our rules. We're going to express each expression as a single logarithm. Notice I have 2 logs here. My goal is to have 1 when I'm done. We're going to simplify if possible, and we're going to check our results by converting the exponent form and evaluating it. All right, so the rule says if we're subtracting, that's the same as dividing them. This is your numerator, this is your denominator. So we're going to rewrite this as one logarithm, log base 3 of 27 over 81. Now, we can reduce the 27 over 81. That becomes log base 3. 9 goes into both, so that's 3 over, actually I take that back, 27 goes into both, so we get 1/3. We divide both by 27. And we're going to check it. So in this case, we've rewritten this as the log base 3. We've written it as one logarithm. We simplified it, and we're going to check our results by converting it to the exponent form and checking. So if I do this, I can take the log of 1/3 and divide it on my calculator. We can't do this on our calculators yet. We have to do a change of base. So we're going to use this rule back over here where it said if we have log base c of a, that's the log base b, which is a 10. We want to convert it to a 10 of the a. So remember, this is our c value, this is our a. We want to make it a log base b of 10. So we're going to rewrite this as log base 10. Remember, when they don't write it, 10 is always assumed to be there. Log base 10 of a, so that's the 1/3, divided by log base 10 of the c. This is a value you can punch in your calculator. You can only do your calculator with a base 10, which is why we had to actually convert it so it would be the same. When you do that on your calculator, you get a decimal equivalent of -0. It's approximately, let me see if I can rewrite that, approximately -0.477. And the denominator, when we do that, we get a positive 0.477 approximate. So that's about -1. So if we think of that, we got the log base 3 of 1/3 is supposed to equal -1. So we're going to use exponents to check it. I don't know if you guys got all that. Here's this above here where I converted it to -1. So let's use our log base b rules. So remember, when we convert things, this is log base b of a equals x. And remember, we want to convert it to b of x equals a. So let's check. B is 3, a is 1/3, x is -1. So we're going to say 3 to the negative first is equal to 1/3. That negative power just flips the 3 over, so 1/3 equals 1/3. And we're good. We checked it. It matches quite up, or matches up well. We're good. Looking at another example, because that wasn't it, we're going to do number 2. Let me see if I can slide the board just a little bit more down. And we'll make this table turn over a little bit. So we have the log base 5 of 1 over 25 plus the log base 5 of 625. Now again, rules of exponents say if you're adding them, that means we're going to multiply them. We can write it as a single logarithm by multiplying them. So the log and the base stays the same, but that's 1 over 25 times 625. So we do need to simplify it. That gives me the log base 5 of 625 over 25. Reducing that down, I get the log base 5 of 25. Now, have to change the base, so we're going to use that change of base formula. Remember, we want to change it so it has a base b, which is 10. Remember, this is your c value, this is your a, so it's the log of base 10 of a divided by the log base 10 of c. You can punch this into your calculator. When you do, you plug it in. For the numerator, you get approximately 1.398, and in the denominator, you get about 0.699. That gives us a value of about 2. So we're going to check. This says that the log base 5 of 25 is supposed to equal 2. Remember, this is your b, this is your a, this is x, so this is log base b of a equals x. And we're going to change it to b of x equals a. So 5 to the second is equal to 25. Well, 5 squared, is that 25? Sure enough. So we're going to practice doing more of these in class. We're actually going to spend 1 to 2 days on it. If we don't have it after 1, we'll spend another day on it. And make sure you take good notes. Make sure you write those rules down.